All right, guys, let's find the second derivative implicitly for the following function. Now, in order to find the second derivative, I obviously have to find the first derivative. So, the derivative of the function would be the derivative with respect to x of x squared plus the derivative with respect to x of y squared equals the derivative with respect to x of 25. Notice the variables match up, so the derivative with respect to x squared would be 2x. The variables do not match up, so the derivative with respect to x of y squared would be 2y dy over dx. And then we know the derivative of any constant is 0, so then that would be 0. Remember, your main goal is to get the dy dx on the left and anything that does not have a dy dx over to the other side. So then the 2y dy over dx equals a negative 2x. And then to solve this for dy over dx, I'm going to divide by 2y, and then that'll leave me the derivative with respect to x simplifies to negative x over y. Now, before you get too excited, we're not actually through, because this is just the first derivative. We have to take the derivative of this function to find the second derivative. Well, I hope you notice that this is a quotient, so I'm going to have to use the quotient rule. Low d high minus high d low all over low squared. All right, so the derivative of this would be low, which is y, d high, the derivative with respect to x of negative x would be negative 1, minus high, which is negative x, d low, the derivative of y with respect to x would be dy over dx all over low squared. Now, before you freak out, we do know what dy over dx is. We found that dy over dx is negative x over y. So all we're going to do is substitute that value into there. So simplify this, and I'm going to get negative y plus x, and then dy over dx is negative x over y all over y squared. I'm going to clean this up a little bit. Positive x times a negative x is going to be a negative y minus x squared over y all over y squared. I want to make sure that this is under the same fraction, so I'm going to put this over 1. I'm going to cross multiply, and I'm going to get negative y squared minus x squared over y all over y squared. This is a complex fraction, so I'm going to stay, change, flip. So I'm going to have negative y squared minus x squared over y. Change this to multiplication and flip it, so 1 over y squared. Now I'm going to multiply across and get negative y squared minus x squared over y cubed. Now notice that you can factor out a negative 1, and there is a reason why I'm going to do that. This is going to leave me y squared plus x squared all over y cubed. The reason why I do that is because if you remember the original problem, x squared plus y squared is 25. So I'm going to substitute this value into this part of the problem where it says y squared plus x squared. So this is 25. 25 times a negative 1 is going to leave me negative 25 over y cubed. And that would be the second derivative. And you can breathe a sigh of relief because that is an extremely long problem.